Here are solutions to quiz 6 for Math 112. In this first one, we're given two of these trig, inverse trig function composition things and asked to simplify them. On the first one, we want to know what's the tangent of the arc cosine of 4/5. The trick to figuring out what the tangent of the arc cosine of 4/5 is equal to, I don't know if I really needed to just rewrite that there, is by giving this thing a name. Is by saying arc cosine of 4/5, let's just call that t. Call it whatever the hell you want, call it some letter. It is the arc cosine of 4/5. And the reason you do that is because then what this question becomes is, instead of figuring out what the tangent of the arc cosine of 4/5 is, all you gotta do is figure out what's the tangent of t. That'll be our answer. Just figure out what the tangent of t is. Okay, that might seem strange. How is that any easier? Well, we can use this information that we have over here. If t is equal to the arc cosine of 4/5, then what that tells you is that the cosine of t is equal to 4/5. And so if the cosine of t is equal to 4/5, I can draw a picture, draw a triangle, take advantage of SOHCAHTOA. If this is t down here, let's see, the cosine of t, cosine is adjacent over hypotenuse. This should be 4. Hypotenuse should be 5. And if I know that this is 4 and this is 5, then this right here, I don't know, maybe I'll call it x. And I know that 4 squared plus, well, this ends up being 3. X is 3. If you don't believe me, I know that 4 squared plus x squared has to be equal to 5 squared. It's the Pythagorean theorem right there. So 16 plus x squared has to be equal to 25. So x squared has to be equal to 9. So x has to be plus or minus 3. But it can't be negative because it's a distance, so x is 3 right here. Anyways, I have this triangle. Here's t. I can figure out the tangent of t. Tangent is just opposite over adjacent. Opposite is 3, adjacent is 4. Tangent of t is just 3/4. Opposite over adjacent. This right here is your answer. Kind of a clever little trick, I suppose, something that'll be very useful in calculus, as we saw on the perfect problem for this week. Really, this example is less useful. It's this example here, when instead of having values in here, you have x. But it turns out we can do the exact same thing that we just did. We could figure out the tangent. Maybe I should switch colors. I want to know the tangent of arc sine of x. I can do that. All I got to do is say, let's let t be equal to the arc sine of x, and then figure out what the hell the tangent of t is, because t is just the arc sine of x. And this is a less daunting question, what's the tangent of t, but we'll get back to that. If t is the arc sine of x, then the sine of t is equal to x. Or if you want, if it helps, instead of x, you can think about that as x over 1. Why it might help is because when you draw your picture, if you draw your little triangle here, we know that, maybe I'll put t over here, put t wherever the hell you want. The sine of t, SOHCAHTOA, is opposite over hypotenuse. In other words, if this is x, this has got to be 1, opposite over hypotenuse. And this thing right here, adjacent, shouldn't have used x there. Well, different problem. Maybe that gets confusing. This side here, my adjacent, I need to figure out. But as long as I have two sides of a right triangle, I can figure out the third side. I know that a squared plus x squared has to be equal to 1 squared. In other words, I know that a squared has got to be 1 minus x squared. In other words, a has to be plus or minus the square root of 1 minus x squared. Note I took the positive because I have a length here and I want it to be positive. Square root of 1 minus x squared. So now that I have all three sides of this triangle, I can figure out what the tangent of t is, because the tangent of t is just opposite over adjacent. So in this case, the tangent of t would just be x divided by the square root of 1 minus x squared. And what I've managed to do is simplify this expression to write it without any trig functions. And that will be an important trick when you're trying to figure out the derivative of the inverse trig functions, which will come up in calculus. All right, second one. We got a triangular mountain between you and me. I guess we live in a two-dimensional world somehow. I am, where the hell am I? From me, it's 45. I guess this is me over here. And from you, you're somewhere over here. If you want to climb the mountain, you have to go up 30 degrees. And it's a 100 kilometer hike from me to you. In other words, this entire distance up here is 100. And I gave you a little hint. I said, think about this as x, and then this is the rest. This is 100 minus x. If you draw your picture like this, it makes this problem a little bit easier to solve. I wanted to help you a little bit because it's a hard problem, but I don't want to help you too much because it's identical to, or very similar to problems that were on the homework. And lastly, I want you to leave your answer as some mess like this. Okay, so what you can do with this picture is we have two right triangles here. We got a right triangle here, so maybe I'll draw these triangles. I got one triangle where this is a right triangle and this is 45 degrees. And on that triangle, I know the hypotenuse is 100 minus x, and the side opposite the 45 degree angle is h. And the trig function that I have that relates the side opposite to the hypotenuse is the sine. So I know that the sine of a 45 degree angle has got to be equal to opposite over hypotenuse. That's the SO in SOHCAHTOA. Then I got another triangle over here. I don't know, you can draw it however you want. I'll do something like this. This is 30 degrees here, and my hypotenuse is x, and this side opposite. Kind of unfortunate that h is the variable I'm using for the height, not the hypotenuse. Whatever, you can probably figure that out. Anyways, again, I want to relate the side opposite my 30 degree angle with my hypotenuse, so it's sine that relates those. So I know that the sine of a 30 degree angle has got to be equal to, let's see, opposite over hypotenuse, h over x. It turns out that now what I have here are two equations and two unknowns I can solve for whatever I need. Sine of 45 is root 2 over 2. It's a point on the unit circle. It'd be good to have that one memorized. Sine of a 30 degree angle is 1/2. So I got these two equations. And what I am going to do is, let's see, I want to solve for h. Eventually, I want my answer to be h. So I'd like to get rid of all the x's. So this one right here, I can solve for x by multiplying both sides by x and then multiplying both sides by 2. I get x is equal to 2h. And if I know that x is equal to 2h, what I can do is jump up here and say root 2 over 2 is equal to h over 100 minus, and then instead of writing x, I can write 2h, because x is equal to 2h. I can substitute in this equation into this equation. Then all I got to do is solve this. Multiply both sides by 100 minus 2h and both sides by 2. Kind of some cross multiplication going there. And I get root 2 times 100 minus 2h is equal to 2h. And if you distribute, you get 100 root 2 minus 2 root 2 h equals 2h. So to solve for h, I want to get all the h's together on one side of the equation. That gives me 100 root 2 is equal to 2 root 2 h plus 2h. What I did is I added 2 root 2h to both sides. And then if you factor out an h from both terms on the left-hand side, you're left with 2 root 2 plus 2. So if I divide both sides by 2 root 2 plus 2, I get 100 root 2 divided by 2 root 2 plus 2. Something like this. This is perfectly fine. You can leave it exactly like this, or if you wanted, you could write it as 50 root 2 over root 2 plus 1. If you want to get really fancy, you could rationalize the denominator by multiplying the top and bottom by square root of 2 minus 1. I'm going to not do that because this kind of says to leave it in this form. So I think either of these are good. So I think I'm going to leave it there, and I'm going to call that the end of this quiz.